Hey everyone, just talking about the powers of I from yesterday. And like we discussed, the powers of I are cyclical, right? We have I to the 0 going to the power, going to 1. Any number to the power 0 is 1. Any number to the power 1, I to the 1 is itself. Remember, I squared is -1. I to the third is -I. And I to the fourth is 1. Now this represents a cyclical relationship. That means it repeats over and over again. So again, we're going to have I to the 5 will be I. We'll have I to the 6 will be -1. I to the 7 will be, if you can guess, -I. And I to the 8 will be 1 again. So it keeps repeating through cycles of 4, right? So just want to bear that in mind. We can look, sorry about this, we can look through the cycles of 4 to see what our I will become in a very complicated problem, right? I'll show you the trick and what I mean, all right? So let's do the easy way first, and then I'll do the technical mathematical way, right? So the easy way you could think about it, right? Since it works in powers of 4, right? So if I have something like I to the 7, right? I could break this up into I to the 4, I to the 3. Now I to the 4 is just 1 from here, and I to the 3 is -I. So I get -I. 1 times any number is itself, -I. All right, so same thing here. Out of the 9, I can break this up into out of the 4, out of the 4, and out of the 1. This is 1 times 1 times any number to the power 1 is itself, so I just get I. So cycles through 4. Now there's a trick you can do through cycling through 4. Right? So let's take an example, right? Let's say I have I to the 70, right? So what do we mean by cycling through 4? First step I want to do is I want to take this power, right? First step, I'm going to take the power 70 and divide it by 4 because it cycles through 4. So after I do that, I get 70 divided by 4 is 17.5, right? Now, I really care about the decimal part. So I'm going to look at the decimal part right here, which is 0.5, right? And I'm going to multiply 0.5 times 4, all right? I'm going to get 2. Because it cycles through 4, every time I get I to the 4, it'll become 1, right? So I can use the leftover, the remainder, to get an equivalent value, right? So I found the remainder here, which is 2. And what I can do next is I'm going to raise I to the 70 is the same thing as writing I to the 2. And I to the 2 is -1, all right? So that's the easy way. Let's do another example using the easy way. So let's say I have I to the 27, all right? Again, I'm going to take the power 27 and divide it by 4. I'm going to get 6.75. Remember, I just care about the decimal, all right? I'm going to multiply 0.75 by 4. I'm going to get 3, all right? Now I'm going to raise I to this new power 3, right? Because I can break this down. I to the 24, I to the 3, right? This, I'll show you in a second. Remember, I only care about this part right here, right? I only care about raising it to this new power because it's a mathematical equivalent, right? So this becomes 1. I to the 24 becomes 1. I to the third is negative I. So my answer here is negative I. All right, let's investigate further why I to the 24 is 1, right? Because it's a multiple of 4. I can break this up. I to the 4, I to the 4, I to the 4. Remember, 4 goes into 24 6 times. I to the 4, I to the 4, 1, 2, 3, 4, 5, I to the 4, 6, and I'm bringing down I to the 3. Remember, I to the 4 is always 1, so I get 1 times 1 times 1 times 1 times 1 times 1 times I to the 3, and I get negative I. So that's kind of the trick, right, to do it quickly with your calculator. We really care about the remainder because I to the 4, whenever I get I to the 4, it always turns into 1. Let's see what happens when it's an actual multiple of 4, all right? Right? Let's say I have I to the, 20, right? So again, I'm gonna divide this new power, 20 divided by 4. I'm going to get 5, right? Now technically, what's the decimal point here? Remember, I said I'm really only gonna care about the decimal, right? Technically, this is 5.0, right? So what's 0 times 4, right? 0 times 4 is 0, right? So again, if I raise it to a new power, remember I'm supposed to raise this I to the 0. Any number to the 0 power is 1. And let's investigate why. This I to the 0 is the same as I to the 20. So if I write I to the 20, right, I could write I to the 4, 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 all right? 1, 2, 3, 4, 5. I can break down I of 20 to I to the 4 5 times, right? This is 1 times 1 times 1 times 1 times 1, which is just 1, all right? So that's kind of the quick trick to finding the powers of I, in my opinion, right? The more complicated way is, if we really want to get technical about it, all right? Let's take, so if you like that explanation, good. If not, I'm going to do something a little more complicated. All right, let's say I have I to the 101, right? We're still going to use our remainders here, right? So I'm going to what? First thing we're going to do, I'm going to divide the power by 4, right? I'm going to get 25.25, all right? Now, I'm going to take into account, right, the 25 and the 2.5, right? I'm going to break up I to the 101, all right? I'll show you what I mean, right? So, I to the 101 is technically I to the 4 times 25 and I to the 4 times 0.25. All right. Again, I to the 101 equals 4 times 25 is 100, right? 4 times 0.25 is 1. So remember our exponent rules, we just add, right? So remember, if I is to a multiple of 4, right, it is always 1, okay? So it is always 1, which represents the cyclical relation. And any number to itself is just itself. So 1 times I to the 1 is just I. All right. So I hope this video helped. Let's take an example of a more complicated problem here, right? So let's try, right? Let's try find f of 2i to the 3rd power, right? And our function here is x squared plus 1. So wherever I see x squared, I'm going to replace it with 2I to the third power. So I see x squared here, right? I'm going to replace it with what I have inside here. 2I to the third squared plus 1, all right? So now, remember our exponent rules, right? I'm going to, nothing to do in here, so I'm going to shift the exponent to the inside terms, all right? So I'm going to have 2 to the second power, I to the third times 2, and I'm going to bring down my plus 1. 2 squared is 4, I to the 3 times 2 is 6, so I added the 6 plus 1. Now, again, going back to some of the tricks we know, remember for over here, what is I to the 6, right? I'm gonna take this power 6, right? Divided by 4, right? I'm going to get 1.5. Remember, I only care about the decimal part. 0.5 times 2, which equals 2, right? So I to the 6, right, is equivalent to I squared, the new power, right? So I raise I to the new power, which is -1. All right, so now I know what I to the 6 is. I'm just going to replace it. 4 times -1, which is I to the 6, plus 1, which equals -4, plus 1, which is -3. All right, and that's my answer. So that's how you would do a problem like that. All right.